The next scheduling algorithm is shortest job first algorithm. Okay. So here we need to, the criteria is burst times. That means we need to take minimum burst time of a process under one criteria. Okay, so here there are three cases that are possible. First one, if a process px and a process py, this particular px and pi have burst times 3 and 2. Okay, now among these two processes we'll schedule py to cpu because py is having lowest burst time or minimum burst time. Then there is second scenario where Px and Py both are having same burst times, that is 3 and 3. Okay. Now what you have to do at this particular point of time, you need to take their arrival times as the consideration. That means if Px arrived at 2, Py arrived at 1, then you need to schedule Py first, then Px. Okay. Then there are certain cases where both burst times are same, they have same burst times and they have same arrival times. Then we need to consider minimum PID. Okay, the process which will have minimum PID, that process will be scheduled into CPU. Okay, so let's see the problem. Again, if they have given a table, we need to, there is no need to write step 1, but if they don't give the table, we need to convert this particular theory into your table. First one, PI, you need to write all four process P1, P2, P3, P4, and they are given in the question that all are arrived at time 0. So 0, 0, 0, 0, and their corresponding burst times 6, 4, 5, 2, 6, 4, 5, 2. Then we need to start with ready queue and Gantt chart. Okay, we need to draw ready queue and Gantt chart. Okay, now let's see here. This is step 2 and step 3. Okay, so now look at here. Here all are arrived at the same time. So arrival time is equals to 0. Okay, but that, and they are arrived in the order P1, P2, P3, P4 with the burst times 6, 4, 5, 2. Now this is our burst time. Okay, now look at here, they are arrived at the same time. Now look at their burst times. So out of these four, at time t equal to 0, which process will be scheduled first? P4 will be scheduled first because P4 has the lowest burst time among these four process 6, 4, 5, 2. So which one will be scheduled first? P4 is the process that will be scheduled first and executed up to 2 units. Okay, time t equal to 2. Then P4 execution is completed. How many remaining? 3. P1, P2, P3. In P1, P2, P3, P2 is having the minimum among P1, P2, P3, that is 4. So we will schedule P2 and it is executed up to 2 plus 4, 6. Time t equal to 6. Then there are two left, P1 and P3, where P1 is having burst time equal to 6, P3 is having burst time equal to 5. So we will schedule P3 to CPU. So 6 plus 5, that is 11. And finally, there is only one process that is left, that is P1. Okay, so we will schedule P1 into CPU. So P1 and its burst time equal to 6, 11 plus 6, 17. So at time t equal to 17, P1 execution is completed. Now let's write their completion time. So this is P4 completion time, this is P2 completion time, this is P3 completion time, this is P1 completion time. So P4 completion time equal to 2 and P2 completion time 6, P3 completion time 11, P1 completion time 17. Okay, then find the formula for find the turnaround times. The formula is CT minus AT, completion time minus arrival time. It will be 17, 6 minus 0, 6, 11 minus 0, 11, 2 minus 0, 2. Then find the average turnaround time, that is TAT minus BT, 17 minus 6, 11, then 2, then 6, then 0. Now find the average. If you find that it is 17, 6, 11, 2. Okay, so if you find the average, you will get 36 by 4. That is number total number the turnaround times divided by 4 processes. That will be 9, and this will be 19 by 4. That will be 4.75. So average turnaround time equal to 9, average waiting time equal to 4.75. Okay, so this you need to write explicitly. Let us go for case 2. Okay, so here you can find the clear numbers. Then let's go for case 2, that is different arrival times. Okay, now look at here. After step 1, this will be our table. Okay, now here first at time t equal to 0, how many processes came to ready queue? Two processes came to ready queue, that is p2 and p3 came to ready queue. What time? At time t equal to 0. Okay, now write down their burst times. P2 is 4, P3 equal to 5. So at time t equal to 0, which process will be entered into CPU? P2, because it is having least burst time, 4 and 5. Okay, so P2 will enter. What is the burst time of P2? 4. So it will execute up to 4 seconds. It will execute up to 4 seconds. And here we need to remember SJF is also non-preemptive. SJF is also non-preemptive scheduling. That means once the process enters, it has to complete its execution. Now, during this 0 to 4, how many processes came to ready queue? At time t equal to 2, P4 came to ready queue. At time t equal to 3, P1 came to ready queue. So P4, which will having burst time 2, P1 which will having burst time 6, where P2 has completed its execution. So how many are remaining? 3. In this 3, at time t equal to 4, we need to find out which process have the lowest burst time. The process which will have the lowest burst time is P4. Okay, so P4 will be scheduled and it will be executed up to 6, time t equal to 6, because it has 2 burst time. So P4 is also completed. Then all the process came to ready queue at time t equal to 3. So how many process left? P3 and P1 is left. So we need to schedule P3 because it is having burst time 5, P1 is burst time 6. So it will be P3 will be scheduled and executed up to time t equal to 11. Then finally there is only one process left, that is P1. So it will be executed up to 6 seconds. So 11 plus 6, 7. Okay, now write down the completion times of each process. P2 completion time equal to 4, P4 completion time equal to 6, P3 completion time 11, P1 completion time equal to 17, and calculate the turnaround times and average waiting times. You will get 17 minus 3, 14, then followed by 4, then followed by 11, 4, and it is 8, 0, 6, and 2. So what will be the average waiting time? The average waiting time and turnaround time, 14 plus 4 plus 8 plus 4, you will get uh, 14 plus 4, 18, 29, and 33. That will get, you will get 8.25. Correct? Yes. Now here it is 8 plus 6, 14, 14 plus 2, 16. So 16 by 4, you will get average waiting time 4. Okay, so these are SJF with different arrival times and SJF with all zero arrival times. Okay, okay, so one more point that we need to discuss is there is a point we need to note, that is we don't know the exact execution time of a process. We don't know. Okay, and it is hard to predict a process burst time. Okay, so what is the statement I wanted to say is SJF is not possible to implement because its criteria is burst time, that is the execution time of a process. It is based on the execution time of a process. We cannot know or we cannot predict how much time a process can execute. So you can, by looking at a process number of lines of code, you cannot determine how much time it will execute. Or by looking at the number of lines of code or the size of the program, okay, we cannot predict it. And because see, there are certain programs which will have 100 lines and executed within some fraction of seconds, within some x milliseconds. Okay, but the same program you can write it in 10 lines by using a loop that will execute for more, say if it is 10 seconds, but this particular program p2 can have only 10 lines of code which will execute for 100 milliseconds of time. And if a program that is not correct, okay, if it is not correct to predict based on the lines of code. Okay, so and we don't know if there is a error in the code, and it may run for infinite amount of time. So the user cannot predict the burst time, that is how much time the process will execute on the CPU, so to complete its execution. Okay, so it is not possible. So that's why SJF is not possible to implement, because we cannot predict the execution time or burst time of a process. But why we are still discussing about SGF? Because the shortest job first will have the lowest average turnaround times and lowest average waiting times, and theoretically it has the highest efficiency, highest CPU utilization and highest efficiency for a system. So FCFS is practically possible to implement, and there are other scheduling algorithms which are practically implemented. So we'll compare all the practically implemented scheduling algorithms of their average waiting times and average turnaround times, and these values which will be closely matched with SJF values. Then we can say that that particular algorithm is efficient. Okay, so why we are using SJF, calculating SJF using SJF, because we can able to find this theoretical average performance of SJF with the practical scheduling algorithms, and find which algorithm is efficient for which type of system. Okay, that's why we are still using SJF.